Alright, in the first video of 6.3 we talked about how to find the component form of a vector. And we saw several different ways we could write vectors. Now we're going to talk about how to find the unit vector. Okay, a unit vector is a vector that has magnitude of 1 in the same direction as the original vector, or a set of vectors or something. Maybe you've got a bunch of parallel vectors and you want to find the unit vector for them for some reason. Alright, so let's say for instance that's what we want to do. Let's look at an example. What if we have a unit vector, we want to find the unit vector, and here's our original vector. It has component parts -2 and 5, which means that this, okay, so when it looks like this, remember it's either in standard form or somebody has gone ahead and subtracted the x's and the y's for you and done a little pre-work for you. You can look at it that way if you get confused by all this notation. Maybe try to find ways to understand it. The unit vector would be denoted by u, and you know, sometimes they use u and it's not the unit vector, so you kind of have to look at the context of the problem and if they say that u is the unit vector. But if I want to find u, the unit vector, what I do is I take the vector v and I place it over the magnitude of v. Okay? And so sometimes they'll write, okay, this is one way to write it. Another way they'll write it is 1 over the magnitude of v. It's v, the original vector. It's hard to read, but that is a v, times v. And these are the formulas that are given in your book. So if I want to find this unit vector and I'm given a vector, all I have to do is go ahead and write the vector on top like this. And what I'm doing is I'm finding the unit vector in component form. So I'm going to have an x part and I'm going to have a y part, if that makes sense to you. Okay. So, but I got to divide it by how big this vector is. This is the component form of the vector, but this has got maybe a magnitude. If you think about what is the magnitude of this anyway, let's go find it out because we need it. If you look, that's what we're going to divide by. We want it to be of length 1. Right now, it's of length, let's see, the magnitude of that vector. Do you remember how to find that? You basically, if you'd had points, you would have had to subtract it, but since we're in this component form, all we got to do is say it's the square root of -2 squared, that's a negative, even though it looks like a dot, plus 5 squared. So that'd be the square root of -2 squared would be a +4, and 5 squared would be 25. So the magnitude of v is 29, and that's what I've got to divide the vector by, basically. So I'm going to divide this by the square root of 29. Okay? And what I would do, just so it would be in the right format, is go ahead and write it. Let me choose black. This is my answer here. -2 over the square root of 29 and 5 over the square root of 29. And we put it like that. And I would accept that as your answer. You do not have to rationalize these. You're not required to do them. Even most textbooks don't make you do that because they realize that that kind of just is a lot more work and it almost obscures what you're doing to yourself when you're trying to learn this. So this would be your answer right here. Yes, you could rationalize it if you wanted to. It would be -2 square roots of 29 over 29 and 5 square roots of 29 over 20 squared over 29. 5 square roots of 29 over 29. But this is fine. Leave it like this. That was less work, and unless you just are so quick at it that you could just do it without having to think very hard. Okay? So this would be the unit vector. This would be a vector in the direction of the original vector, and this would have a length of 1. It's in standard form or component form, so it would be, if I wanted to draw a representation of this vector, I could put the initial point at 0, 0, and I could put the terminal point at this, whatever this decimal divided out to be at, and that would be a good representation of the unit vector, a vector of length 1 in the direction of the original vector. Okay. Vector, if I have a vector v, let's use that same vector there, what was it, negative 2, 5? It's in component form. Okay, and I could do things like this. I could say negative v. What would negative v be? It would just be changing the sign of the component. So negative 2 would be, it'd be like saying a negative 1 times the vector negative 2, 5, if you want to look at it that way. And you just, basically, you're just changing the signs. If you remember, multiplying by a negative 1 just changes the signs. So that would become 2. Negative 5 would be what negative v would be equal to. I could take two vectors and add them together. Let's say I have a vector r, and it is negative 6, 3. I could say v plus r, and what I would do is just add the x parts together for the x part or x component. So it would be negative 2 plus negative 6, which is what, negative 8. That would be the x part. And then I could do the y part. I could add it together. I could say, well, the y parts of those two vectors are 5 and 3. So 5 plus 3, which would be what, 8. So I could add those vectors together and get another vector, v plus r. Okay? I could subtract vectors. If I had, let's see, vector v was negative 2, 5, and let me do w this time just because I don't remember what I wrote on that previous slide, and I can never really go back and look once I'm recording, or it just shuts the recording off and won't go back. I could say v minus w if I wanted to. Okay, so what I would do is I would subtract the x parts. They go together where I'm subtracting, so I'm going to subtract like, it's almost like subtracting like terms if you think about it. So it would be negative 2 minus 3 for the x part, and that would be what, negative 5. That's a comma. And then for the y parts, there they are. If it's v, we start with v minus w, so it's going to be 5 minus 4, and then that would be 1. So that would be the result of subtraction. I could even have v minus 2w if I wanted to. So I would say that would be negative 2, 5, and then I'm going to subtract twice w. So what I'm going to do is I'm going to say 2 times w, 3, 4, okay? So let me just do this a piece at a time. That's negative 2, 5, minus, and I just distribute the 2. 2 times 3 is 6, and 2 times 4 is 8, so I can subtract that. That would be, if I'm looking at my vector, negative 2, and then remember there's a minus here, so minus 6, that's the x part. I'll do the y part in a different color. I'll just go to green. And 5, and then we have the minus sign right here, and then we're supposed to subtract this 8 here. Okay, so when I get done, negative 2 minus 6 would be negative 8. Remember, if negatives is a problem for you, don't forget, if you're on a test or quiz, check your work by using a calculator, because you don't want to miss the problem and have the concept just because you subtracted wrong. And by now, you have a tool to use it. So I'm going to start counting the problem wrong if you subtracted wrong, because you've got to learn how, if you can't do that accurately, you've got to learn how to get around that, because you've got to do that for tests and quizzes, and when you get to college, you know, it's not going to be an excuse. It's all right or all wrong in college. There's no partial credit. So 5 minus 8 on the y part here is negative 3. Okay, so that would be the answer of v minus 2w. Another idea I want to make sure, if they say that you have the 0 vector, that means it's like the vector 0, 0. That would actually be a point, wouldn't it? Because you can't go, if this is in standard form, you can't go from 0, 0 to 0, 0 and create a line. It's the same point, so you're just at a point. So we call that the 0 vector, and if you think about it, the magnitude of that vector would be, I'll call it vector z or something. The magnitude of vector z would be 0, because if you did it, remember how you do it's really just saying 0 squared plus 0 squared, which would be the square root of 0 plus 0, which would be the square root of 0, which is 0.